Is Earth the only livable planet in the universe?
What if Earth was not even the only livable planet in our galaxy?
Could we someday be living on another planet?
What if we lived on a super Earth? Today on What If Discussed. Welcome to What If Discussed. I'm Peter Smeechin.
And I'm Richard Garner. So Pete, if you had to describe our planet, Earth, in one word.
One word.
What would that word be?
Well, I'm going to guess this is a trick question, and you're asking me this because of the title of our show today, which is Super Earth. So I'm going to say, the Earth is super.
The Earth is super.
Yes.
But it is not a super Earth, according to current scientific definition.
Okay.
So again, super Earth is a term that you might have heard of over the last really few years. It's not much older than that. It's during this time where we're finding a lot of exoplanets. Super Earths obviously meet a certain category, and I won't continue to speculate. I'll go to our friends at Universe Today, and their definition of a super Earth is a planet with more mass than Earth, but less than a larger planet like Uranus or Neptune. So you could have super Earths made of rock and metal, or even ice and gas. These planets could have oceans and atmospheres, or made of nothing at all, like, except maybe hydrogen or helium. But the goal, of course, is to find a rocky super Earth that's located in a habitable zone. So super Earths aren't necessarily conducive to human life, but we're looking, and we're continuing to look to find that perfect sort of super Earth that might also be conducive to human life.
Yeah, well, we're not there yet.
Not there yet.
But it does seem like in the past couple of years, I had never heard the term habitable zone or Goldilocks zone before, and it seems like in the past couple of years, every other week, we're hearing about a new planet that could potentially house human life.
Yes.
Wow.
4,000 or so exoplanets, I believe, something around that, have been discovered over the last X amount of years. It feels like we're going to be discovering more as we go. But yes, it's gotten to the point where it's not even like it's like number 7 on the list of news stories on the site. Yeah, we discovered a new exoplanet. Before, it was like, oh my God, we discovered an exoplanet. Now it's like, we're like, meh, whatever.
Yeah. Is it possible to live there? Hard for us to speculate, but you know who can?
Our guest today?
That's right. Let me introduce you to him. Jack Madden graduated in 2014 from Franklin and Marshall College with a BA in astrophysics. While at F&M, he worked with Dr. Fronefield Crawford on an extragalactic pulsar survey and also on pulsar identification algorithms. He's now a fourth-year PhD student in the Department of Astronomy at Cornell University.
Dr. Madden, thanks for joining us.
Hey, it's great to be here.
So we've heard a lot over really the past few years about exoplanets and the discovery of exoplanets and super Earth. So it's an exciting time, obviously, to be an astronomer. But for those people who aren't astronomers, it is a bit of an enigma that all super Earths are exoplanets, but not every exoplanet is a super Earth. Do I have that right?
Yes, yeah. And I apologize on behalf of all exoplanet scientists for the confusion. We sort of use these terms loosely because we know that they're going to change over time. So we started discovering all these objects, we needed a name, and we went with super Earth, and that term has evolved. So the term is really how you might describe Jupiter and Saturn as like gas giants. It's sort of a subset, a category of planets that is defined roughly by size. So the term super Earth, it used to mean anything really between an Earth-sized planet and a Uranus-sized planet. But now we've really narrowed that down to mean something that's terrestrial, something rocky like Earth, that goes up to about 1.75 Earth radii. And that gives us a mass between 1 and maybe 6 or 7 Earth masses.
Wow. How have advancements in technology, and specifically telescope technology, changed the game in searching the galaxy for exoplanets, super Earths? What can we expect from the launches of the future super telescopes? Because a few are coming up, right?
Yeah, so astronomy is really driven by the design of telescopes. Um, we've seen thousands of exoplanets discovered with the capabilities of Kepler. TESS is going to find 1,000 more. So we're really looking now towards characterizing these exoplanets. So we have all these planets. What do we do now? We want to learn more about them. We don't know too much just from their detection. We know that they exist, but what are they made of? What are they like on the surface? And the real push now is for detecting and looking at the atmospheres of these super Earth and rocky planets like the Earth. So that's where these huge telescopes come in, and they're really gargantuan. These 30-meter class ground-based telescopes and these sort of 10-meter class space-based telescopes that are still concepts. And those will have the capabilities of learning more about super Earths.
Yeah, it's an exciting time to be an astronomer, and your work specifically uses Earth's own evolution to help with the discovery, almost as a template to help discover and find super Earths. Can explain to us how that works?
Yeah, so part of my research involves modeling the climates of potentially habitable exoplanets. This allows us to sort of know what to look for and know what to expect as these measurements start to come in. And when you're dealing with habitable planets, we really only have the Earth as the only example that we can build our models off of. So when you build these models, you need sort of this ground truth to make sure you're doing it right. And we don't want to venture too far away from that, just so we know that we're doing it, within the bounds of reason based on the only example we have. But the trick is that the Earth's atmosphere has changed over time. It's been quite different in the past, but still inhabited by life. So we can look at the geologic record and see what the atmosphere was like on Earth in the past and use those as templates to a point where we don't have just one example of a habitable planet, but we have several, but it's just the Earth through time.
What do we know currently about exoplanets in terms of some of their more basic but vital measurements like oxygen and atmosphere levels?
Yeah, so these measurements are really hard to make. We've mainly just found a bunch of exoplanets, and the sort of special cases, the largest ones and the hottest ones are things we can actually get information about in terms of composition. We haven't really looked at the compositions of Earth-like planets, very small, colder planets. So we don't know too much there, and that's where these big telescopes are going to come in. We do have some information about like Jupiter-sized planets and what their atmospheres are structured like and what those are made of, but nothing at the scale of an Earth-like planet.
So let's talk gravity, shall we?
So, yeah.
Well, I mean, in this particular case, it's probably, and you correct me if I'm wrong, the most important variable we're dealing with. We know how important gravity is as a force in the universe, and obviously as it affects life on this planet. But one of the things we also know is gravitational pull. The bigger it is, it affects things like asteroids coming into your orbit. We know about mass extinction events, the dinosaurs, et cetera. Are some of these super Earths potentially living with maybe so much gravitational force that it might get in the way of them developing long-term evolution and civilization because maybe they're getting pounded by asteroids? Is that an oversimplification?
No, that's definitely an interesting question, and I think there's a lot of competing factors. Yes, when you have a larger planet, it's going to have a greater sort of sphere of influence gravitationally, so it'll pull in more asteroids. And as they're coming in, they're going to speed up more because you have a greater gravitational pull. So they'll be faster than if they were coming into Earth. You have to, though, consider that the main effect on the speed of an asteroid is really going to be the relative motion of the planet and the asteroid as they orbit their host star. So the planet's going to be orbiting around, the asteroid's going to be orbiting around too, and those velocities can be much higher than if you were to sort of just drop an asteroid to a super Earth. There's also the effect that these super Earths might have thicker atmospheres which can really put the brakes on a meteor. But so I think that expanded gravitational influence is really going to cause some interesting cases for asteroids and extinction events, which could be greater.
And so gravity has not only effect on space debris like asteroids and whatnot, but tell us about the effect of gravity and how it pertains to like water and magnetic fields and us.
Yeah, so there's a lot of theories floating around about this, and it's really fascinating. I think it's the most fascinating thing about super Earths right now is the strange conditions they can create for these different things just based on their increased gravity. So things like the magnetic field, if you have more mass on a planet, you might actually end up freezing, sort of solidifying its dynamo in its core, which actually could reduce its magnetic field. There's theories maybe that could be other elements that could create a magnetic field for these planets, but you might end up with a smaller magnetic field. In terms of geologic activity, a larger planet's going to have more internal heat. You might have more activity on the surface as that heat is trying to escape. And then water is a really interesting thing for super Earths. I think it's one of the most fascinating parts of this to theorize about is that we're finding some super Earths that might have a large fraction of water, so much greater than Earth. So these planets might be covered in a very deep ocean. And what that does when you have a deep ocean on a very massive planet is you might actually get ice to start to form at the boundary between the ocean and the seafloor. And this ice is very strange ice. It's not like ice we're used to, where the molecules are cooled down and crystallize into a solid. This ice is formed just by the pressure alone. So the molecules are just packed so tightly together that they form a solid. And this can have some really strange consequences for things like the evolution of life, how plate tectonics are working, and a whole host of different cycles that affect the atmosphere. Because you're sort of creating this layer between the ocean and the seafloor that's impenetrable. Usually water can sort of interact with the rock at the seafloor. You can transfer all sorts of chemicals. Life can get started there. But once you put this layer down, you're sort of stopping a lot of these cycles, and it can have some pretty disastrous consequences if you think of life starting on the seafloor or how a planet might regulate its temperature in terms of these like feedback cycles.
Well, I mean, it's a very interesting time, like I said, to be an astronomer because we're probably at the tip of the iceberg in terms of the discovery going forward with, like you talked about, the improved technology, improved telescopes, more exoplanets, more super Earths. But still, what you've also sort of pointed out is the question still remains whether any of the conditions on some of these super Earths are conducive to at least creating life that we would understand to be quote unquote intelligent life. But still more to unpack as we go forward in the years and decades to come. Thanks so much for taking the time to join us today to shed light on what's really fascinating, a fascinating time to be alive, to be honest. Where can people find more about your fascinating work?
Yeah, so you can look for my website, jmadden.org, on Instagram and Twitter, or you can just Google me to find my recent papers.
Fantastic.
Keep looking into the universe for us, and obviously we hope that maybe one day we're all talking about that great discovery by Dr. Jack Madden. And if you're thinking of planet names, Peter, Richard, just to consider. Okay, thank you, and we'll catch up with you down the line.
Thanks so much.
Yep, thanks.
So yes, lots to discover out there in the galaxy, exoplanets, super Earths, but for the time being, our focus is still here on Earth with our everyday issues and our everyday problems. One of those being, I don't know, finding insurance.
Well, yeah, it's you're right, because when you find the right policy, you save big bucks, and that's what we all want to do. With everything going on right now, Richard, in the world, exoplanets aside, people are asking, is it even possible to buy life insurance? Are you asking that question?
Well, it's a good question because in normal times you'd say, of course it is, but now things change when, let's say, risk goes up. People might be wondering, is anybody even selling life insurance? And if they are, at what cost? But obviously they would need somebody to help guide that process, not only to find it, but also, I guess, to find the right one.
Policy Genius. Yeah, you can buy life insurance during a pandemic, and if you have loved ones depending on your income, you definitely should. Policy Genius is an insurance marketplace. They're in contact with insurance companies on their platform every day, keeping track of all the changes in the market so that you don't have to, which means you can get covered quickly and for the best price. Here's how it works. Policy Genius compares quotes from the top life insurance companies all in one place. It just takes a few minutes to compare quotes from the top insurers to find your best price. This doesn't save just legwork, like I say, price. You know how much you could save, Richard?
$1,500.
How do you know this?
Well, I'm a genius.
You certainly are.
I'm a policy.
You could save $1,500 or more each year by using Policy Genius to compare life insurance policies. So, if you're one of the many people looking to buy life insurance right now, but you're not sure where to start, head to policygenius.com. Policy Genius will find you the best rate and handle the process completely. They'll get you and your family protected and give you one less thing to worry about.
And again, plenty of things to worry about these days.
Every day.
Which is why I enjoy a show like today, because we get to sort of zoom out maybe out of our everyday issues and be able to talk and think about things like exoplanets, super Earths, etc. And we're lucky enough to talk to people like Dr. Jack Madden, who has sort of opened our eyes to a few different things. I don't know about you, but I mean, first of all, the excitement about what is to come, not what's been discovered with these super telescopes that are coming down the line. I mean, I can't even imagine. I'm almost like a kid in Christmas, because you can just sort of, you can speculate, but as far as where we're at now, what we understand, I don't know, one of the biggest takeaways for me is that, kind of pump the brakes here. The gravity, everything else. I think the initial exoplanets meant other Earths that were habitable, like for a lot of people. Super Earths sounded like better Earths.
Yeah.
It doesn't sound like that.
It's a misleading nomer.
Yeah, it's
a misnomer.
A misnomer, if you will. But it does sound like, in the end, the astronomers that are working through different models and obviously technology that we have now have been able to speculate enough things about atmosphere, oxygen levels, and gravity to feel pretty confident that there's no discoveries as of yet where we could say, well, there's probably an intelligent species there at this particular time, but TBD.
To be determined.
To be determined.
Well, if you like this episode and want to spend more time on the topic, click on the link in the description below. We have an extended audio version. We'll be back with more of Dr. Jack Madden in it, and we'll carry on the conversation with exoplanets, super Earths, and anything else we can find out in space.
Yes, lots out there.
But thanks for joining us today on What If Discussed.